day. So when it says find the product, that means to do what again? What's product? That is one method. It means to multiply. And when you are multiplying stuff like this, you're either foiling or box method. Okay? So take up a few minutes to do 1, 2, and 3. And do it because it really does pertain to what we're doing today. You have to divide out a 12. Okay, so 12 times 1 minus 4m squared. Boom. Okay, hey, it doesn't matter that the m squared is the second thing. They're both perfect squares. I can take the square root of this and the square root of that, and I can write this as two binomials. So, what's the square root of 1? I don't. 1 and 1, right? That's all I care about. What's the square root of 4m squared? 2m. So that goes on the end, and that's fine. It's perfectly legitimate. There is no middle term, so what goes in the middle? Plus and minus. You've factored it. That's your answer. These are all answers here. That's all you had to do. I should circle them, and I didn't. Okay, you do this one on your own. Make sure you can't FOIL. You got to take something out first, and then you've got to put it into the binomials. Okay, so I divided out of 4 first, and I got y squared minus 16. I know that 16 is a perfect square. I can take the square root of it. So I have y plus 4 and y minus 4. If you wrote y minus 4 and y plus 4 is fine. Okay? These are called the sum and difference pattern. What does sum and difference mean? Add, subtract, right? Add, subtract, sum and difference. Sum and difference pattern. Okay? This only works when you start with a subtract or minus, subtract or minus. Let's look what I mean by that. See, that started with a minus, a minus, a minus. They all started with a minus. You can't do this unless it starts with a minus, okay? But it's way easier if you start to recognize it. All right, the next thing we're going to talk about is a perfect square trinomial. It's when you multiply a binomial by itself twice. Actually, it's only once, but let's just cross that off. The resulting trinomial is called a perfect square trinomial. So if you do this, x plus 1 squared, that equals x plus 1 times x plus 1, which equals x squared plus 2x plus 1. I just know how to do that in my head. I don't expect you to do it that fast. This is a perfect square trinomial right here, because this is a perfect square and 1 is a perfect square. Okay, let's see about this. To factor a perfect square trinomial, just take the square root of the first and last term and check that you are using the right sign, and I'll teach you that. So how do you know? I know that I can take the square root of s squared and the square root of 9 and have a whole number, can I? 9 is a perfect square, s squared is a perfect square. So I'm just going to start by trying my two binomials. I'm going to put my two things down. I know in the front has to go a what and a what? S and s. S times s has to be s squared. Then, if I take the square root of 9, what do I get? So I'm going to put a 3 and a 3. Now, slow down here a second, because we have to figure out what goes in here. And there's something you look at. If you have a plus and a plus, so we started with a plus and a plus, then you're going to end up with plus, 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 plus. So inside here, you do plus and plus. It's multiplying a binomial by itself. It gives you a perfect square trinomial. So I can rewrite this as this. Now you could put either way. It doesn't matter. I don't care. Now let's do another one. So I have 4n squared plus 20n plus 25. Can I divide anything out of those? There's nothing in common. But I notice that 25 is a perfect square, 4 is a perfect square, so maybe I can just do this. Let's just try it. What's the square root of 4n squared? 2n. That has to go in the front, because 2n times 2n is 4n squared. What's the square root of 25? That goes at the end. I have plus, and I have plus, so what goes inside my binomials? Plus, 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 plus. Now you say, maybe some of you are thinking, Mrs. Burgess, how do you know you're going to end up with 20n? If you want to check, you can box, or if you just look at this, just say, okay, I know if I FOIL kind of in my head, if I FOIL the outer terms, that gives me 10n, right? You see that? And I FOIL the inner terms, that gives me 10n. Those are alike. When I combine 10n and 10n, I get 20n, don't I? So if you're just, you know, a bit skeptical, it does work. Okay, let's do one more. So I'm going to stop and look at this and say, can I divide anything out? I can't, but I know I can take the square root of that and the square root of that, so maybe I can just jump right in and do this. What's the square root of 9c squared? What has to go in the front? 3c. I know Garrett keeps answering that, and I hope you all can see it. 3c times 3c is 9c squared. Then I have to take the square root of d squared, which is just what? D, because d times d is d. Now be careful. This one's a little different. What's different about it? Yeah, I have a minus and a plus. That means in my binomials, I have a minus. Minus plus minus. If I have a minus plus, I'm going to have a minus minus. And if you were just to think about the outer term and the inner term, it would total negative 6d. So you could write it like this. So basically, two special patterns that will help you factor really quickly if you recognize them. That's what we're doing here. Could you do the box? Absolutely. It's quicker if you recognize these patterns. Okay, turn it over. Let's practice a little bit more. All right, the directions here are to factor. Take out the greatest common factor first and then factor. Okay, so wait a minute. Be careful. We have a what here? Yeah, let's get rid of that. Not just a -1, but a what? Let's take out a -2. Put that out front and rewrite your trinomial. So it'd be x squared plus 8x plus 16. You could do the box. Or you could say, wait a minute, I can take the square root of that and I can take the square root of that. I probably don't need to do a box. It's really quick and easy. So I'm just going to set up my binomials and see if I can make this work. What's the square root of x squared? And the square root of 16 is 4. So on the end I put 4. It's a perfect square trinomial with plus, plus, what am I going to put in here? Plus, 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 plus. Now I could rewrite this as this, but I wouldn't be picky if you did either one of those. And then you're done. Okay? Let's do another. Let's do these two because they're both kind of different. So here I can divide out a 2. I got to do that first, always. And then I'll see what I'm left with. You could jump in and do a box, or you could recognize again that this is a perfect square and that's a perfect square. I can square root both of those. So I'm going to just set up my binomials. What's the square root of 25? Now stop a second and say, oh, wait a minute, it's a minus and a plus, so inside here I have to do what? Minus. Minus plus minus. Okay? This one's a little funky, so we're going to do this one and then 2 on the bottom and we'll be done. So I'm going to divide out of 3 because I can. I can't take anything else out. You might say, yeah, but there's no numbers there. It doesn't matter. I can take the square root of x squared and I can take the square root of y squared. So that is also a perfect square trinomial. So I'm going to set up my 2 binomials. X and x, y and y. X and x make the first term, y and y make the last term. Plus plus what? Plus. Boom. Okay? All right, let's just do these first 2 here. All right, solve. Now I have to actually find out what the variables are. So first, is it set equal to 0? Check that always. Greatest common factor. Can I pull something out? Then you factor, then you solve for the variables by setting each factor equal to 0. All right, are you freaking out because there's a fraction? Don't freak out. Really. It's okay. We'll be fine. So it's set equal to 0. I can't divide anything out, but wait a minute. 25 is a perfect square, isn't it? 4 is a perfect square, yes? So 25 over 4 is also a perfect square. Isn't that nifty? So let's just set this up. Let's see what happens. I can do x and x. Now, I'm going to go down here and say, okay, if I have 25 over 4 and I take the square root of that, what is the square root of 25? 5. What's the square root of 4? There you go. That's the square root of 25 over 4. So I put that in my binomials. What is it, plus plus or minus? Yes, because it's minus plus minus. Now, I set each one equal to 0, and I got to solve. Basically, it's going to be the same number, which is what? If you add 5 halves to both sides, x equals 5 halves. That's your answer right there. You only have to do it once because it's the same number. Let's go over here and do this last one. What's the difference between this kind of problem and this kind of problem? What's the difference? Yeah, this is a trinomial, a perfect square trinomial. This has no middle term. It's like the first set of problems that we did. Remember? But still, this is a perfect square and so is this. So I'm going to set up my binomials. I have n and n in the front. What's the square root of 81? 9. However, I have no middle term. So what goes inside there? Plus and minus. In order to eliminate that middle term, you have to have the opposite signs in the middle. Okay? Because you just started without a middle term. So then you set each factor equal to 0. Because you got to solve for this one. Subtract 9. N equals negative 9. Add 9. And n equals 9. So there you go. Basically, all this is about is recognizing when you have a sum and difference pattern, no middle term, that you can factor that easily. And when you have a perfect square trinomial, you can factor that easy. They're not all going to be like that, but for this section, that's what you're working with. Got it? Okay.